Welcome to the channel. Suppose first time you are looking the channel, please subscribe the channel. Now in this video we are discussing inverse trigonometric functions, important problems. Important problems in the inverse trigonometric functions for final examinations. Now the question is here, show that cot of sine inverse of root 13 by 17 is equal to, this is sine of tan inverse of 2 by 3. Now here in the solution, what we have to prove that this is LHS and this is RHS. We have to prove that LHS is equal to RHS. Now you take, let this inverse angle sine inverse of root 13 by 17 is equal to some angle A. Now from this we get sine A is equal to root over 13 by 17. See, which is can be written as what? Sine A is equal to, so root 13 by root 17. So we know that sine is what? Opposite by hypotenuse. So if you take a right angle triangle here, suppose A, B, C, so this is sine is root 13 opposite by hypotenuse, so this is root 17. So now what we get here? So we have to find the adjacent. So now here AC square is equal to AB square plus BC square. So now from this, so what is AC here? So root 17 whole square is equal to, so AB square we have to find plus BC square. BC square is root 13 whole square. See, from this we get square and root gets cancelled, 17 is equal to AB square, so plus this is also square and root gets cancelled, we get 13. So now here AB square is equal to 17 minus 13. So from this AB square is equal to 4. So from this AB is equal to 2. So AB is equal to 2 here. AB is equal to 2. When AB is equal to 2, then if you take, so cot of sine inverse of, so root 13 by 17, so which is becomes what? When it is A, sine inverse of root 13 by 17 is A. So now which becomes, this is cot A. Now cot A is equal to what? See, from this cot what we can write? Adjacent by opposite. So what is adjacent here? Adjacent by opposite. So what is adjacent here? Adjacent is AB by opposite. Opposite is root, that is BC. Opposite is BC. So that's why which is adjacent is AB, that is 2 by opposite is BC, that is root 13. So clearly we get here, we get that cot A is equal to, so 2 by root 13. 2 by root 13. So cot A is equal to 2 by root 13 means, so what is here? So A is what? Sine inverse of root 13 by 17. So that's why, therefore, so cot of sine inverse of, so root 13 by 17, so is equal to, we get the value 2 by root 13. 2 by root 13. So this is what LHS. This is left hand side. So LHS is equal to, we get this is. Now taking here LHS, suppose we have here cot of sine inverse of root 13 by 17, we get 2 by root 13. Now similarly taking suppose RHS. So this is LHS, right? So now RHS. So RHS is what here? Sine of tan inverse of. So 2 by 3. So now what I am doing is same like LHS. Same like LHS. So here let tan inverse of 2 by 3. You take the angle B here. You take the angle B here. Now from this what we get? So tan B is equal to, so 2 by 3. So tan is what? Opposite by adjacent. So now if you take a right angle triangle, suppose like this A, B, C. So tan is opposite by, so adjacent, this is 3. So here BC square is equal to, now BC square is equal to, so AB square, so plus AC square, so which is equal to, AB square is 3 square plus AC square is 2 square. So we get this is 9 plus 4. So BC square is equal to 13. From this BC is equal to what? So root 13. BC square is equal to 13. From this we get BC is equal to root 13. So when you get BC, what I have taken here, tan inverse of 2 by 3, B only, no? So then what we get here? So we get, so therefore, so sine of tan inverse of 2 by 3, so which is equal to, so sine of, when I have taken this angle is B, so then this is sine B. Now I am finding from this right angle triangle sine B. Sine B is what? Opposite by hypotenuse. So sine B is equal to opposite by hypotenuse. Sine is opposite by hypotenuse. So opposite is here AC, by hypotenuse is BC. Hypotenuse is BC, which is equal to, so opposite is AC, that is 2, by hypotenuse is BC, so that is root 13. That means finally we get what here? Sine B is equal to root 2 by root 13. So what is B actually here? I have taken B is a tan inverse of 2 by 3. Is it or not? So therefore sine of tan inverse of 2 by 3 is equal to, so 2 by root 13. Observe here, so RHS sine of tan inverse of 2 by root 3 is equal to 2 by root 13, and here, so LHS cot of sine inverse of root 13 by 17, which is also is equal to 2 by 13, 2 by root 13. So both the values are same. So therefore LHS is equal to RHS. Therefore LHS is equal to RHS. Like that we can say that cot of sine inverse of root 13 by 17 is equal to sine of tan inverse of 2 by root 3. So hence proved. Hence proved.